Hopefully you had some success with the solution. If you didn't, if you struggle with the problem, that's totally fine. It's really what I would expect, to be honest. I'd be really surprised if many people got this problem correct on the first time through. This is one of the classic problems where the first time you do it, it's really hard, but then when you attempt the solution a second time, life gets a lot easier, just like every other interview problem there is. And that's why you're here. You're here to practice the problem one time so that when you go and do it in an interview setting, it's much easier. Okay, so let's start going through our solution. As we go through the solution, I'm going to be alt-tabbing back and forth over to this diagram quite a bit. I know that's really distracting in a video. I apologize for that, but I want to use this diagram a lot to really show you exactly why we are writing the code that we are. So let's get started by doing step one right here, which is to create an empty array of arrays called results. That's step one. So inside my function, I'm going to create an empty array. And then the number of subarrays that are going to be pushed into this thing is dependent on the value n. So I want to have n number of subarrays inside of results. So we're going to have to iterate with a for loop from 0 up to n, and for each step, we're going to push in an empty subarray into results. So I'll say for let I equals 0, I less than n, I plus plus. And then for each step, we'll take the results array and we will push in an empty array. If we were now to console log out results, we would see something like, let's assume that we have an n of 2 right here, we would see something like this. So for an n of 2, we would have 2 empty subarrays inside of one larger one. Now, a key behavior or a key feature of arrays that is really important for our solution here is the fact that we can assign values to indices inside of an array that have not been initialized. In other words, let's look at a quick example of this. In other words, if I declare an empty array right here, so it has no spaces inside of it, no values, nothing, I can freely assign some value to, say, index 3. And if I now print out ARR, notice how that value was assigned to index 3 right here. I did not have to push this value in, or I did not have to unshift the value into the array. I can just freely assign any value to any index inside of an array that I want. And it's a very important thing to keep in mind with this solution here. Okay, so back over here. So our next step is going to be to create a counter variable starting at 1. So I will say let counter equals 1. So that's going to be the thing that actually keeps track of what number we are attempting to push into our results array right here. The next thing we're going to do, and I did not specifically put this on the diagram right here, we are going to create a number of variables that keep track of the current column, the start column, the end column, the start row, and the end row that we are trying to consider at any given time. The start column and the start row will always be initialized to 0. But the end column and the end row, their values will depend on the value of n that is passed into our function. So to calculate the end column and the end row, we'll take n and subtract 1 from it. So to calculate this matrix right here, or to produce this one, we would have been given an n of 3. And so the last index that I want the last index I want to consider would be n minus 1. So 3 minus 1 would be 2. So with that in mind, let's declare those 4 variables. We'll say start column is going to start off at 0. The end column that we want to consider during this first run through will be n minus 1. The start row will be 0, and the end row will be n minus 1. Cool. So now we're going to move on to the next step here, which is to somehow make sure that we are going to execute all of this code right here as long as this statement is true. So that's a classic case for a while loop. We're going to use a while loop here. We're going to say while start column is less than or equal to end column and blah, blah, blah. We want to execute these code blocks right here. So let's write out that while loop. We'll say while start column is less than or equal to end column and start row is less than or equal to end row, execute some code inside of here. So just to make sure it's really clear at this point, start column and end column, start row and end row, all of these little counter things right here, they're going to change over time. So these are not fixed values that we just assigned right here. We are going to change the value of start column, start row, and so on to indicate which row, which column, and so on we are currently working on at any given time. Now that we've got our while loop put together, we're going to start on our first for loop. The first for loop right here is always going to be responsible for assembling the top row of our solution. So this first row right here. After that, we will define the next for loop. The next for loop will always be responsible for defining this row on the right-hand side. And then there's the two other for loops that I did not indicate on this diagram right here. One of them is going to be always responsible for assembling the values here on the bottom. And then the last one will be always responsible for assembling the left-hand side of our solution. And then we'll enter the while loop again at the very top, and this first for loop will then be responsible for assembling the top block here. So essentially, we've got these four for loops, and each of them is responsible for assembling a different side. And then each time we progress through the while loop, we're going to be constraining these start row, start column, and end column to control what section of the matrix each loop is attempting to create. All right, so let's get started with this first for loop right here. So for the first for loop, I'm going to give myself a comment here. I'm going to say this thing is responsible for the top row. We are going to iterate from I equal to not 0, but our start column. So we're going to iterate from our start column, which is going to start off at 0 right here. We are going to progress through this for loop as long as I is less than or equal to end column. And for every step through, we will increment I by 1. Now inside of that for loop, at every step along the way, we are going to assign some value to the results section, or the results array, excuse me. So at our results start row at I, we will assign the counter variable. So inside of here, results at start row, at I, we will assign the counter, and then immediately afterwards, we will increment the counter. And then after the for loop, and this is the really critical part right here, after we put this last line of code, or this next line of code, we'll take a second to kind of iterate, or to kind of imagine this first for loop and what it's really doing for us. So after this first for loop, we will then increment the start row. So immediately after the for loop, we will increment start row plus plus, like so. Okay, so we've got one for loop put together here. Let's look at this on the diagram and really picture what this thing's purpose is. So we are iterating from start column to end column. We then put something into our results set, and then we increment start row. So let's see what the result to that is. So we are going to increment from 0 up to 2. At every step along the way, so from 0, 1 to 2, we are going to look at our results set. At the results set at the index 0, or essentially start row, and at the particular step through the for loop that we are at, we will assign the counter variable. So we start off at index 0 for start row, 0 for I, which is right here. We assign the counter variable. We then increment I by 1, which moves us over here. We assign the counter variable. We increment I by 1, which moves us over here. And we assign 3. At that point, we have now iterated all the way from the start column to the end column. So we're all done with this first for loop right here. We have assembled the top row. So we exit this first for loop, and then we execute this next line of code, which is to increment the start row. So start row has served its purpose. We have assigned everything in this first row right here. So we are now going to increment start row by 1, which means this is now the first row that we are going to be concerned with inside of our solution. So now start row is going to be 1. So now let's consider the next for loop that we are about to put together. We are now going to iterate over from start row to end row, so from 1 to 2. Inside of there, we're going to look at results I at end column. So now we have flipped our indices here. End column at this point, inside this for loop, end column is always going to be equal to 2. And we are going to have values of I ranging from 1 to 2. So essentially, this for loop right here, the next one that we're going to write, we are going to iterate from results at 1 at 2. So results 1, 2, and that would be this index right here. We will then increment I by 1, and that'll then move us on to results at 2 at 2. And for both those steps, we will assign our counter variable. So let's go through that process right now. I know this is some pretty crazy stuff, but this is the kind of things that you got to answer in an interview to get those very high-paying jobs. All right, so this is going to be our right column. We're going to iterate from I equal to our start row. So remember, we are iterating from 1 to 2 now because we want to go from this spot to this spot. So we're going to start at our start row. We're going to iterate as long as I is less than or equal to end row, and we'll increment I by 1 each time. And then for every step along the way, we will assign results at I at the end column equal to our counter variable. And then we'll increment our counter variable by 1. All right, so again, this is taking us from this spot right here to this spot right here. Now, immediately after we achieve that, after we get through that for loop, we have now taken care of this entire column right here. So we no longer need to consider this column. So we're now going to decrement end row. So we're going to take end row and we're going to shift it over 1 to right here. So now end column is going to be equal to 1. So now we need to repeat these two for loops right here for the other two sides, specifically this bottom row and then the left column over here. Now again, I did not put the for loop on here, but I think you get the idea of what's going on. So for the end row, we are going to want to iterate from the end column. So we're going from right to left now. We're going from the end column down. So we are now decrementing. We are decreasing here. We are iterating from the end column down to the start column. For every step along the way, we are going to assign some results, and then results right here, and then we will decrement our end row. So end row will be subtracted by 1, and we would now be considering just this row right here. So let's give that a shot. All right, so this is now going to be our bottom row. And for this thing, we're going to say from let I equal to end column. So we're starting off right here at our end column. As long as I, in this case, remember we are decrementing in this case, so we're going to flip a lot of these conditions. We are decrementing from I down to 0. So as long as I is greater than or equal to our start row, or excuse me, not our start row, but our start column. Typo. So from I, as long as I is greater than or equal to our start column of 0 right here. So from this guy over to this guy. And then every step along the way, we are going to subtract 1 from I. Then inside of here, we'll say results at end row. So that's, we are looking at this subarray right here. So our end row at I, we're going to assign counter. And then we will counter plus plus. And then the really critical part right after the for loop right here, and I just realized we made a mistake on the for loop right above. We'll fix that in just 1 second. So immediately after our for loop right here, we need to make sure that we move our end row up. We have now taken care of everything inside this end row, so we're going to shift it up by 1, which means we are going to subtract 1 from end row. So we'll say end row minus minus, like so. Okay, really important, tune back in here for a second. I completely neglected to update our column counter right here. So for that second loop, for this second loop right here that we just put together, we needed to decrement the end row immediately after it. Is that it? No, we need to decrement the end column. This should be decrement end column. So the end column was over here. We need to subtract 1 to get it to this column right here. So we are going to end column minus minus, like so. All right, last step here, I promise. I know this is brutal, but very last step. So this is going to be our for loop for the start column. So this is going to be, it's kind of boring on this 3x3 one. It would have been a little bit more interesting if we had a 4x4 matrix to look at, but we are now going to iterate from essentially right here up to here. So we're going to go from our end row down to our start row. So we will iterate from let I equal to end row, I greater than or equal to start row, I minus minus. And then for every step along the way, we're going to assign results at I with start column, because remember we want to assign at column 0 right now, and we're going to assign the counter here, and then increment the counter. And then immediately afterwards, we have now taken care of our start column right here, so we now need to move it inwards over here. So I'm going to increment start column by 1. So start column plus plus like so. Okay. Whew. That's nasty, but that is all. That's it. That's it right there. So after we finish that start column, we will then go back up to the top. So we will execute the while loop again. We will check to see, let's check all of our bounds here. So we now have a start column of 1, end column of 1. This should be end column of 1 right here, and a start column of 1. So all of our columns are now 1. So we're only looking at this right here. So we'll now check the while loop. We'll say, is start column less than or equal to end column? And yes, it is. They're both 1. And is start row less than or equal to end row? And yes, they are, because they're both equal to 1. So we're going to execute all of our for loops one more time. And it's probably going to be this for loop right here that captures that very last placement of the number. So we'll start off with 1 here, 1 less than or equal to end column. Yeah, so it'll be this one right here. We'll assign that very last number. We will not satisfy any of our other loops inside of here, and so we will then exit our for loop, or excuse me, exit the while loop, and then the very last thing we have to do is return our results set. All right, let's check our tests, see how we're doing. So over here it looks like my tests are running, which means I probably have a typo somewhere due to an infinite loop. So let's check our solution here really quickly. I'm going to check against my notes just to make sure we've got the right thing. We've got I, start row, end column, end row, and then start column plus plus. All right, so we definitely have a typo somewhere here. Oh, you know what? We need to restart the test. That's what it is. So if your test stopped running, it's probably because they entered into an infinite loop. I'm going to restart my tests by running jest matrix test.js -- watch. There we go. All right, so that's the problem. We've got an unexpected token here somewhere with the counter. Here it is right here. I'll fix that. And now the tests are passing. Okay, I know this has been a brutal section. I know this has been very brutal. If you were not able to follow through all the way, I really recommend you go and check out the GitHub repository for this code and walk through the code and take a look at all the bounds on these for loops. Honestly, this problem, it does make a lot of sense as soon as you understand how we are defining the start column, end column, start row, end row variables, and then kind of constraining our solution window over time to spiral inwards. That's what this problem is all about. It's all about recognizing that you want to have some variables to keep track of the current range that you are trying to fill in on the matrix at any given time. Again, I know this solution has been kind of brutal. To be honest with you, I have recorded this solution 4 times now, and I think that this one has been the first time that I actually came across at least somewhat clearly. So I think this is gonna be it. This is the video you're probably gonna be watching. I tried recording this 3 other times and it really just didn't quite work out. So hopefully this has made some sense. So at this point, hopefully you've got some idea of how the solution is put together. I would really encourage you to maybe delete the solution entirely and try it again. Put the solution together on your own at least one time so that you can feel at least somewhat confident in an interview setting of communicating to an interviewer about what's going on here. Okay, so very tough problem, but we have seen it one time, so you've got at least some idea of how to approach it. Let's now take a break. We're going to continue the next section and start working on our next problem. So I'll see you in just a minute.